All right, hello again. In this lecture, we're going to learn about taking a fraction and changing it into a decimal. And the beauty of taking a fraction and changing it into a decimal is that it's long division. And it's long division until you have a no remainder. So let's start off with probably the nicest one. Let's use these as our directions. So let's change a fraction to a decimal, and we'll start with 1/2. So what we're going to do is remember we always have a numerator divided by a denominator. And this ordering really is useful to keep track of. You have a numerator divided by a denominator. That denominator is what's dividing into the numerator. So I've stated that 3 times purely because I really want you to focus in whatever's in the bottom is dividing into the top. It is not necessary that the top be smaller than the bottom or vice versa. It's always whatever's in the bottom, in this case 2, dividing into the numerator, which is 1. Now, we all know that 2 can't go into 1 evenly. So we're going to fling a decimal point at the end of the 1, and we'll line it up top. And now I'm going to write something that is equivalent to 1, 1.0. 1.0 is the same thing as 1. And I can fling a 0 as many times as I want. I could add millions of them at the end of this, and I'm never going to change that it's still 1. So we can add infinite number of zeros to the end. I'm going to add them one by one, slowly. So now I ask myself the question, what times 2 will get me close to 1? Well, nothing. So nothing. Subtract. We got 1. Bring down the next digit. And I added in that 0, right? Now I go, what times 2 will get me 10? And that's 5. And that's exactly 10. And now I'm ending with a remainder of 0. Now I can stop. So we stop as soon as we have a remainder of 0. And there's no more significant digits to bring down. Like, there's nothing here, right? I added in this 0, so I could get something other than having a remainder of 1. So we keep on adding zeros until we stop. So now 1/2 is the same thing as the decimal 0.5. Or you could write 0.5. Either or work. Let's do a couple more, just to get the practice. The next one we're going to see is not as nice. Let's say we have 1/3. Now, whatever's in the bottom is dividing into the number up top. And I'm just doing a nice one just to get us started. So we'll add a decimal point at the end. We'll fling a 0 behind it because it's still 1. And now we'll go, what times 3 gets us close to 10? And I'm skipping the first part. Yeah, we know 3 times nothing will get us the 1, right? So that's not really necessary for me to do. 3 times 3 is the closest we'll get to 10. We'll subtract. We got 1. Now I can't stop because I have a 1 there. I keep on going until the remainder is 0. Or something else happens, which we're going to see in this one. So I'll fling another 0 at the end. And I'll bring it down. And I go, what times 3 gets us close to 10? Okay, 3 is the closest we'll get with 9. Subtract. And I got 1. Well, that's not acceptable. I'll fling another 0, so I'll extend this out. And I can add as many zeros I want, right? I told you guys that was okay. So we'll bring down the 0. 3 times 3 is 9. Subtract. And now this is feeling repetitive, right? I've done this 3 times. I've been getting the same thing. And look, I'm going to bring down another 0. And it's still going to be the same sad story. This is what we call a repeating decimal. Because this is going to continue on forever and ever. You could keep doing the long division and you'll keep getting 3 times 3 is 9 and you have a 1 left over, bring down a 0. You'll go on forever until you're blue in the face. So we'll write 1/3 is the same thing as the decimal 0.3 repeating. And it's very important we have that bar up above that 3 there. And I'm just going to exaggerate it in red. That line there is telling you this is a repeating decimal. And excuse my pen, it has issues. I do try to dot my I's. Okay. What we had before was what we call a terminating decimal. So let's sneak back to our first problem here. This ended, right? We ended with a nice 0. that is our most preferred fraction to decimal form. And we call that a terminating, like terminator, right? It ends. And I can't spell terminating. Ugh, decimal. Always double check my spelling. You know how bad it is by now. So those are the two types of fraction to decimals we'll have. We'll have either a terminating one or we'll have a repeating one. So let's see something that's a little bit funky. Let's say we are asked to convert from a fraction to a decimal, and we have 11 over, I don't know, 6. Now, remember, I told you, whatever's in the bottom is what's dividing into the number up top. It is okay that the top is bigger than the bottom. In our previous two examples, this did not occur. Now, we'll fling a decimal point at the end, toss a couple of zeros, maybe only one at a time, however many you want, and let's go ahead and do the long division now. Make sure you line up your decimal points. Now, 6 can go into 11. In fact, it can go in there at least one time, right? And 11 minus 6 is 5. We'll bring down the 0. This whole number is before the decimal point because it could go into it at once. Now we'll go, what times 6 gets us close to 50? Well, 6 times 9 is 54, so that's too much. Let's try 8. And 6 times 8 is 48. Subtract. We got 2, bring down the 0. Now, 6 times 3 is the closest we'll get to 20. We got 18. Subtract 2. Let's fling another 0 at the end here and bring it down. So we keep adding zeros until we either terminate or we see a pattern. 6 times what gets us close to 20? Oh, it looks a little bit familiar. 3, 18. Oh, this definitely feels familiar, right? We could keep on going on and on forever. But now we've reached a repeating. But only the 3 is repeating. So, 11/6 is equal to 1.83, and my bar is only going over the 3, because only the 3 repeats itself, right? If you keep on going, you'll see the pattern occur. Be very careful. Don't let your bar get adventurous and cover over the 8. So this is our answer. Let me go into more details about the repeating bar. If you were a little bit of a messy writer and you wrote this instead, where that bar went over 2 of the digits, what this means to us is we have 1.83838383, right? You're getting bored of hearing me say that. Repeating, right? Keeps on going on and on forever. My ... suck. But the bar is saying both digits repeat. Versus if the bar is only over 1 digit, only that single digit repeats itself. So be very, very careful with your bar notation. Now, some bad habits, besides the bar getting crazy and covering more letters than it should, is this. And this I should never see from you. Now, you might be saying, Miss B, that's the same thing as this guy, right? And I'd say, yeah, you're kind of right, because 1.8, now 3 repeats itself, so you have 3, then 3, then 3, keeps on going, right? And these look identical. But this is repetitive. Remember, we write this notation here to reduce the amount of writing. If you add an extra 3 with a bar over it, you're saying the same thing, but less efficiently. So this is bad. This is ugly. Why would you write the same thing when you can write much fewer digits in the same notation? So if I ever see this, I will scribble all over your paper and cry. Don't drive me to drink, okay? So that is all for fraction to decimals.